In this question, we have a molecule made up of iodine and fluorine, and we're going to find out if this is a polar or non-polar molecule. So we're going to look at our electronegativities, which are provided in the table. And our first step is to find the magnitude of the difference in our electronegativities. So we're just going to subtract them. 3.98 minus 2.66 equals 1.32. So that's our difference in electronegativity, 1.32. And anytime our electronegativity difference is greater than 0.4, we have a polar bond. If it's less than 0.4, we have a non-polar bond. So this bond is going to be polar since the difference in electronegativity is much greater than 0.4. So yes, this is a polar bond. Okay, next we're going to have a look at our molecule. So we're told in the question it's square pyramidal in shape, and we're shown that square pyramidal structure in the diagram. And the question's asking, is this fully symmetrical or is it asymmetrical? So you can see with this shape, we've got these 4 spokes sticking out evenly, and then we have an extra spoke sticking upwards. So if you imagine you looked at this from the top, you'd have that spoke coming out towards you. But if you looked at it from the bottom, there wouldn't be any spoke coming out towards you. So this one is asymmetrical. Lastly, we need to figure out if this is a polar or non-polar molecule. So to do that, again, I'm going to draw on my polarity arrows for each of my bonds. Since fluorine is the more electronegative element, my arrows are going to point from iodine towards fluorine, like this. So there's one, there's another. So there's my polarity arrows drawn on my diagram. And if we think about it, this arrow and this arrow are pointing in opposite directions. So those 2 arrows are going to cancel each other out. Then this arrow and this arrow are pointing in opposite directions. So those 2 arrows are going to cancel each other out as well. However, this arrow here that's pointing upwards doesn't have anything to cancel it out below because there's no atom attached here. It's an empty space with a lone pair. So as a result, we do have a dipole on this molecule as a whole because it's asymmetrical. So is this a polar or non-polar molecule? It's polar. The reason why is that it contains polar bonds and it is asymmetrical. So finally, which arrow would we draw onto our molecule? Well, that arrow that remains that we haven't crossed out, that's our overall polarity of this molecule, and it points upwards. So I can select arrow 1 from our list as the one that shows the correct direction of the dipole on this molecule.